Dear friends, I am Dr. Santosh Desai and I welcome you all to my YouTube channel. So in today's session, I am going to discuss how to find Laplace transformations of integrals. So first we will see the rule, and by using that rule we will solve these three examples. So let us consider first rule. So if Laplace transformation of f of t is equal to f bar s, then Laplace transformation of integration 0 to t f of t dt is equal to. So its Laplace transformation is given by, this is 1 divided by s into Laplace transformation of f of t. So this is the rule to find out the Laplace transformations of the integrals 0 to t. So here you note that if the integral limits are 0 to t, then you can apply this rule. Otherwise, it is not applicable. So to use this rule, first to find the Laplace transformation of integrand, that is, you first neglect that integral sign, and after neglecting whatever the function remains, find the Laplace transformation of that function and divide it by s or multiply it by 1 upon s. So you will get the Laplace transformation of 0 to t f of t dt. Now let us consider the examples. So the first one. So we have, now here you have to find out Laplace transformation of 0 to t 1 minus e raised to t upon t. So if you apply the rule, if you apply this rule to this example, then you will get. So applying the rule, here we get Laplace transformation of integration 0 to t 1 minus e raised to t divided by t dt is equal to. Now the rule is 1 upon s into Laplace of f of t. But what is f of t? F of t is nothing but your integrand. So here integrand or f of t is this function. So this is f of t. So here we get this is 1 upon s, and you have to multiply 1 upon s to the Laplace of this function. So it is Laplace transformation of 1 minus e raised to t divided by, and call this is equation number 1. So if you write the first step, if you write this step, then automatically you will get the idea to find out the Laplace of 1 minus e raised to t upon t. Now our next job is to find the Laplace of 1 minus e raised to t divided by t. You have to find out this one. Now let us consider this. So now consider Laplace transformation of 1 minus e raised to t divided by t. This is equal. Now to find out this one, we have to do the division by t rule. So the division by t rule is, so Laplace transformation of f of t divided by t is equal to, this is s to infinity Laplace transformation of f of t ds. So this is the rule. So here, whenever there is a division by t, you have to take integration. Integration s to infinity. But integration of what? Integration of Laplace transformation of numerator. So it is Laplace of 1 minus e raised to t, and Laplace is a function of s, and integrate it with respect to s. Now find out the Laplace of 1 minus e raised to t using linearity property. Integrate between the limits s to infinity. So you will get the value of Laplace of 1 minus e raised to t upon t. Substitute this value in equation 1. You will get the Laplace of 0 to t 1 minus e raised to t upon t. Now next, let us consider this next one. So this is equal to this integration sign, keep as it is, into Now Laplace of 1 minus Laplace of e raised to t. But Laplace of 1 is, this is 1 upon s, minus Laplace of e raised to t. This is 1 upon s minus 1. Now take the integration. So again use the rule. So rule we know, that is integration of f dash x divided by f of x dx is equal to, this is log f of x plus. So you have to adjust the derivative of denominator to the numerator. So the derivative of s with respect to s, that is 1, already it is in the final form. Similarly, derivative of s minus 1, it is also 1. So using this rule, we get. So the value of first term, it is log s, minus value of the second one, it is log s minus 1. And the limits are s to infinity. Now next, log s minus log s minus 1 can be written as, it is log of s divided by s minus 1. The limits are s to infinity. Now substitute the upper limit. So when you put the upper limit, you will get infinity divided by infinity minus 1. So this is an indeterminate form. So in this case, you pick up the highest degree term from the numerator and denominator. So from the pick up highest degree term from the numerator and denominator and divide numerator and denominator by that term. So in the numerator highest degree term is yes, in the denominator highest degree term is yes. So in the both numerator and denominator highest degree term is yes. So divide numerator by yes and denominator by yes. So we get, this is log 1 divided by 1 minus 1 upon s. Limits are s to infinity. Now when you put again, when s tends to infinity, this 1 upon s tends to 0. So when s tends to infinity, this 1 upon s tends to 0. So denominator will be 1, and 1 divided by 1 is 1, and the value of upper limit is log 1. And for the lower limit, you have to replace s by s. So the term remains same. It is log of 1 upon 1 minus 1 upon s. Now we know that log 1 is 0, and simplify to this, we get, this is log of, this is minus log of s divided by s minus 1. And remove this minus sign, so we get log of s minus 1 divided by s. So this is the value of Laplace of 1 minus e raised to t upon t. So you will get the value of this term. This term we get. Now substitute here and you will get the required answer. So therefore, by equation 1, so Laplace transformation of 0 to t 1 minus e raised to t divided by t dt is equal to, this is 1 upon s, and the value of this Laplace, that is log of s minus 1 divided by s. So you will get the Laplace transformation of this one. Now next one. So the next is, there is this. So for the second, again we have, so first you apply the rule. First you apply the Laplace transformation of integral and then you simplify the next. So here we have Laplace transformation of integration 0 to t e raised to minus 2t t into sine cube t dt. The value of this is equal to, so integration sign is there, so that means this is 1 upon s, and 1 upon s into Laplace of this integrand, so this function. So this is your f of t into Laplace of e raised to minus 2t e sine cube t, e raised to minus 2t e sine cube. Now this is 1. Now we have to find Laplace of e raised to minus 2t t into sine cube t. Now there are 3 terms, but if you observe that there is a one exponential function. So whenever the given function contains exponential function, that means you have to apply the first shifting property. So whenever there is a problem of first shifting property, you always apply first shifting property at the end. So that means first you find Laplace of sin cube t, then apply multiplication by t, and then apply first shifting property. So you will get the Laplace transformation of this function. So first I will find Laplace of t into sin cube t. So let us find first Laplace of sin cube t. Now we have sin 3t is equal to 3 sin t minus 4 sin cube t. This is a well-known formula or result, we know this. So from this we will find the value of sin cube t. So sin cube t is equal to, let us shift this term to the LHS and shift this term to the RHS. So we get sin cube t is equal to, this is 1 upon 4 into 3 sin t minus, you will get sin t. So you will get the value of sin cube t is equal to this one. Now you take the Laplace of sin cube t. Then Laplace transformation of sin cube t is equal to 1 by 4 is a constant term and into Laplace of 3 sin t minus sin t. So you get this one. Now using linearity property. So first Laplace of sin t minus Laplace of sin 3t. This is equal to 1 by 4 into, now 3 is the constant term, keep as it is. Laplace of sin t, this is 1 divided by s square plus 1 minus Laplace of 3 sin t, this is 3 divided by s square plus 9. So we get the value of Laplace of sin t. One can simplify this also. From the numerator take 3 common, so we get 3 divided by 4 into, this is 1 upon s square plus 1 minus 1 upon s square plus 9. So we will get the Laplace of sin cube t. So this is what, this part is what. Now it is multiplied by t. So by multiplication by t rule. So therefore Laplace transformation of t sin cube t is equal to, this is minus 1 d by ds Laplace of sin cube t. So this is a multiplication by t rule. Now we have the Laplace of sin cube t, so put the value. This is equal to minus d by ds Laplace of sin cube t is here. So this is 3 by 4 into 1 divided by s square plus 1 minus 1 divided by s square plus 9. Now you have to take the derivative. So 3 by 4 is the constant term. Let us take it outside. 3 by 4 into. So the derivative of 1 upon s square plus 1. So it is minus 1 upon s square plus 1 bracket square into 2s, and derivative of this is minus, here you will get, this is minus 2s divided by s square plus 9 bracket square. Okay. Now here is the simplification. So from the numerator one can take 2s common. So this is equal to, so here is also minus 2s, here minus becomes plus, otherwise you give this minus sign inside the bracket, and let us take 2s common. So this 1 2 cancel with this 4, and you will get 3s divided by 2 into, this minus and this minus becomes plus, so it is 1 upon s square plus 1 bracket square. Already minus plus, and due to this minus, this middle sign will be minus, and this is 1 upon s square plus 9 bracket square. So you get Laplace transformation of this next part, that is t Now once you know the Laplace transformation of t into sin cube t, then apply first shifting property to get the Laplace transformation of e raised to minus 2t t into sin cube t. So therefore, by first shifting property, we get Laplace transformation of e raised to minus 2t t into sin cube t is equal to. So to apply this first shifting property in the Laplace transformation of t into sin cube t, you have to replace s by s plus 2. So the Laplace of t into sin cube t, that is we know, and in the Laplace of this, you just replace s by s plus 2. So we get, so 3 into bracket s plus 2 divided by 2 into 1 divided by, now the other term is s square plus 1. So it is s plus 2 bracket square plus 1 and then bracket square minus, this is 1 divided by, it is again s plus 2 bracket square plus 9 and x bracket square. Now simplifying this, so this is equal to 3 into s plus 2 divided by 2 into 1 divided by. So the simplifying denominator, you will get s square plus 4s plus 5 bracket square. X square is s square plus 2s plus 4 and plus 1. So we get plus 5 minus 1 divided by s square plus 4s plus, it is 4 plus 9, so you will get 13 square. You will get this. So this is the Laplace transformation of e raised to minus 2 t into sin cube t. So therefore, by Laplace transformation of integration 0 to t e raised to minus 2t t into sin cube t dt is equal to, so here 1 upon s is already there, into Laplace of this remaining function. So here is the term, so you put this one. So it is 3s plus 2 divided by 2 into, I'll write the main terms here. So it is 1 upon s square plus 4s plus 5 bracket square minus 1 upon s square plus 4s plus 13 brackets. So this is the required answer. Now last one. So in the last example, if you observe that there is an exponential function but it is outside the integral sign. There is an exponential function but it is outside the integral sign. Now exponential function means first shifting property, and to apply the first shifting property you have to know the Laplace transformation of remaining terms excluding that exponential function. So first you have to find Laplace of this 0 to t sin square t upon t. First you find Laplace of, you first exclude this exponential function and find the Laplace of integration 0 to t sin square t upon t and then apply first shifting property. So I will first find Laplace of this 0 to t sin square t upon t. So we have Laplace transformation of integration 0 to t sin square t divided by t dt is equal to. Now you just go on applying the rules. Now the integration sign is there, so that means it is 1 upon s into Laplace of this integrand, that is sin square t divided by. So you get this. Now again here division by t is there, division by t, so this is equal to 1 upon s. So whenever there is a division by t, you have to take integration from s to infinity. But integration of Laplace transformation of numerator. So you will get sin square t and ds. Now you just find out the value Laplace transformation of sin square t and integrate it between s to infinity. You will get this value. So this is equal to 1 upon s integration s to infinity. Now the Laplace transformation of sin square t. So for the sin square t, we have it is 1 minus cos 2t divided by 2. Now 2 is the constant term. Let us take it outside and use the linearity property for Laplace of 1 minus cos 2t. So this is equal to, this is 1 upon 2s integration s to infinity, and here first Laplace of 1, this is 1 upon s, minus Laplace of cos 2t, this is s divided by s square plus 4, and then integration with respect to s. Now you have to take just integration of this 1 upon s and s upon s square plus 4. So this is equal to 1 upon 2s. So let us take the integration. So the integration of 1 upon s, this is log s, minus. Now here you have to adjust the derivative of denominator to the numerator. But here s square plus 4 is the term, its derivative is 2s, and out of 2s only s is there. So that means you have to write 1, 2 here, and here you will get 1 by 2. 1 by 2. So therefore this 1 by 2 as it is, and now derivative of s square plus 4 is the 2s, and therefore you will get log of s square plus 4, and limits are s to infinity. Now again you have to use log a minus log b property. Now before that we have to simplify this one. So let us take 1 by 2 common again. So you will get 1 upon 4s, and here 2 times log s minus log of s square plus 4, and limits are s to infinity. Now again here it is, you can't use again log a minus log b, because you check the coefficient of log s, it is 2 and you have to make it 1. So this 2 log s can be written as log s square minus log s square plus 4 and s to infinity. Now you can use log a minus log b. So this is equal to 1 upon 4s log of s square divided by s square plus 4, limits s to infinity. Again you will get the same problem as we have seen in example 1. So it is infinity upon infinity. So in that case, you pick up highest degree term in s from numerator and denominator and divide both numerator and denominator by the same term. So in the numerator it is s square, in the denominator also it is s square. So divide numerator and denominator by s square. So we get 1 upon 4s log. So divided by s square you will get 1, and here it is 1 plus 4 upon s square, and limits s to infinity. Now when s tends to infinity, this 4 upon s square tends to 0. So upper limit will be log 1 minus, now this terms remains as it is, log of 1 divided by 1 plus 4 upon s. Now simplifying this we get, so this is 1 upon 4s, log 1 is 0 and minus, so simplifying this we get log of s square divided by s square plus 4. This is equal to, again you just remove this minus sign, so 1 upon 4s log of s square plus 4 divided by s square. So here we will get the Laplace transformation of 0 to t sin square t upon dt is equal to this one. we'll get this value. And let us check here. Now, except this exponential function, you will get the Laplace transformation. So, to find Laplace of this exponential function into this, you have to apply the first shifting property. So, therefore, by first shifting property, we get Laplace transformation of e raised to minus 2t, then integration 0 to t sin square t divided by t dt. So to apply the first shifting property, you have to know the Laplace transformation of remaining excluding that exponential function. So Laplace of this function, that will be here is the term, and e raised to minus 2t is there. So you have to replace s by s plus 2. So everywhere I will replace s by s plus 2. So this is 1 upon 4 into s plus 2. Then log of, here you will get s plus 2 bracket square plus 4 divided by s plus 2 bracket square. So this is the final answer. Now one can just simplify, into one, you just simplify the squares. So you get 1 upon 4 into bracket s plus 2 log of s square plus 4s plus 8 divided by s square plus 4s plus 4. So this is the final answer. So in this way, if you know the properties, if you know all the properties, then just by applying step-by-step properties, one can solve the examples on Laplace transformation. So this is all about Laplace transformations of integrals. In the next part, we will see Laplace transformations of some standard functions, that is periodic functions, unit step function, etc. So for more videos, please subscribe my YouTube channel, and thank you so much for watching.